Hi, so what I wanted to show you in this video is how you can use the serial code blocks, which are found in the advanced section here, to monitor what's happening in real time on your microbit. So firstly, you need to be using the Chrome editor, and the Chrome editor lets you pair your microbit with the computer, and this will work on both Mac and Windows machines. I've already got mine paired, and if it's paired with something previously, you might be having trouble pairing yours. So to start fresh, or if you're having any problems, go up to this padlock symbol up here and just reset permissions, and that deconnects it, and we can start again. So I have to reload. Now I can go to these three dots here and click Connect Device and go Next and Next again. My microbit appears here. One thing to check actually, if it's not appearing, you might want to make sure that you're using the right type of USB cable, because there's two types of USB cables. Some of them are just for power and some of them do data as well. So the black ones that came with your microbit will do data as well as power. But if you're using one that you have around the place, there could be a chance that it only uses power. So if that happens, if you're not seeing your microbit there, try changing the cable that you're using. Once you've selected your microbit, click Connect, and you can see I'm all connected, and that's done. Now that it's connected, when I hit the download button at any point, it downloads it directly to my microbit. So I don't have to go through the process of saving it to my hard drive and then downloading it to the microbit. It does it in one step. So that's really useful. So what I'm going to do now is I'm going to use the serial blocks to monitor what's actually coming in from my light. So I'll go to the advanced section and click on the serial section. And I'm going to grab this one that says serial write value x equals 0. And I'm going to put that in the forever loop. I can delete my start loop because I'm not using it. And what I want to do is I'm going to write the value light level. This is a string, it's in inverted commas. And I want to set the light level, I want it to show me what the actual light level is. So I'll go to my inputs and I'll choose light level and drag it into this number section here. You can see that now I'm using light level in MakeCode. My light level appears in the simulator, and the light level, you can tell as I drag it, it goes from 255 to 0. But while it has these two extremes, I don't necessarily know what the ambient lighting in my room is. It might not be 0, it might be 0 when the room is totally dark. I don't know if I can get the brightness up to 255. And so this is useful for me to find out what's actually going on with the sensor. So what I'm going to do now is click the download button, and it's downloading to my microbit here. Takes a little while, and there it is. And you can see now that I've got two options. I can show the console for the simulator, which is really no use because, well, if you want to simulate it, that's fine, but it's not going to tell me the real world data that's coming from this microbit. So I'm going to click Show Console for the device. And now I can see that I'm getting a constant reading of my light level, and this number is how many times it's read the light level, or it's put this amount here. And we've got it also represented as a graph, and it's at 0, which is kind of surprising because there's light in this room here, but there we go, that's what's happening. I'm going to use the torch on my phone. Well, give me 1 second, there we go. And as I bring the light up, you can see that my graph is changing. I'm going to go off, just go to my torch again and turn the brightness up. You can see, so this is my torch at the absolute brightest. And I'm getting up to values around 247. If you look over on the right hand side here, you can see my top and bottom values that have happened in this graph. And you can see the current light level is here in the left with the orange background. And as I move my phone away, it goes back down. And so I can get this graphical representation of what is happening with my device. So that's really useful. I can now use that data to control other factors or other outputs. I'm also getting it mentioned here. You can also choose to export this data. I believe it's as a CSV file. Yep, I've saved a CSV file here, which is a comma separated values file, which you could export to an Excel table, among other things, or web data. See, it's going up and down as I'm moving my phone closer and away. You can also pause this. Say you've sort of worked out your main values. I can hit the pause button and it stops moving, or it stops recording the console information. So yeah, that's using the simulator, and you can use this for anything. So if I could take light level out for now and use a different input. So I'll need to use something that represents as a number. So I think temperature does as well, although that's not really going to change much. But let's see how warm it is in my room. So I will click the download button again. Give it a second. I doubt this is going to vary much. Oh, 29 degrees in here. It's warm. I don't know where the sensor is on here, but I'm just going to put my hands over it and see. Oh, yep, there we go. I'm increasing it. 32 degrees. I wonder if it will go up as high as my body temperature, which should be around 36 or 7. No, we're stopping at 34, so there we go. And if I take my hands off it again, it might take a little while, but it should drop back down again. Or not. Or maybe it's going to take quite a while to drop back down again. Let's try something else. So that was the temperature. So we could do the acceleration in milligrams. And we can choose which axis that we're going to go on. So X, Y, or Z. X is left and right, Y is up and down, and Z is backwards and forwards. And I'll download that again. Oh, no, sorry, download, not show console. Wait for it to download. And let's see, so it's still right now. You can see it's still saying light level here, and I might just go back and change this so that I'm telling myself actually what I'm seeing. So I'll put X acceleration. I'll just download that again. It doesn't really matter what's written here, but it's good to write something useful so you can tell what's going on. Now let's see. So my X acceleration it's a little bit wobbly. You can see it's not such a stable reading. I'm getting about 40, 48. Now if I move it, you can see I'm getting values between -1324 and 1728. And that's it upside down. And I can move it all the way back around and around again. If I do it faster, there we go. So this allows you to really get the numbers that are being created by the sensors in your Microbit, which allows you to do all sorts of other things. And I'll make another video showing you now how to map these numbers to control something like pitch. I'll just put this back the other way. Oh, no, okay. There we go. So you can also use this to do something like to react to another type of input. So I could say if button A is pressed, let's write the words you have pressed button A. So this is also really useful for debugging. I'll download that, and so notice that I can have two serial writes happening at once. So let's show the console for the device. So I've got my acceleration being monitored, and once I press button A, you can see that, yeah, I've pressed button A. It doesn't come up in the graph because it's not something that is changing over time, and it's not something that's in the forever loop. If this was in the forever loop, it would be showing up constantly. You can see once I press it again, if I press it a few times really fast, if it was the only thing here, I'd be getting a number next to it, but because it's being on the next line, we've got acceleration, it's not doubling up. So if you're not sure if a pin is actually registered as being pressed, for example, you could use the on pin 0 pressed function to see what's going on. And let's do this. Let's get a start loop, and let's use. Go to our more section in the pins, and let's actually test out how the capacitive touch works. So firstly I need to set my pin 0 to be touch mode capacitive. By default it's resistive, but we want capacitive, and that means I only need to press the pin for it to be registered. And on pin 0 pressed, I'm actually just going to use this one, and instead of writing you've pressed button A, I'm going to say you've pressed pin 0. And I'm going to test how they work with multiple pins. So I'm going to put pin 1 in here too, because I noticed that the capacitive touch can be a bit funny. So if I want to debug what's actually happening, this is a really great way to do it. So I'll add another serial here. I'm going to delete this one because we don't need that. And I'm going to write you have pressed pin 1. And I actually need to put that in a pin 1 press, not in the same as pin 0, or they both show up when I pressed pin 0. Make this pin 1. Okay, so now let's download that and see how it goes. Okay, so now I'm going to press pin 0. Oh wait, I will press pin 0 because it wasn't letting me show the console until I did something that activated the console. So now I can see the console. It says I've pressed pin 0 and I've pressed pin 1. I want to see what happens when I press both at once. It only registered 0. I must have pressed 0 slightly faster. It seems to let me press between them quite fast and still register. So yeah, this is a good way to debug if pin 1 or pin 0 is being too sensitive. You can sort of see why it's happening here. Okay, so I hope that helps and that you'll be able to use the serial to debug or to find out what sort of number values you're getting from your sensors.